Hello, and welcome to this video where we are going to discover the power of Python problem solving in just one line. I will leave the rest for you to read from README file. Alright, so let's now jump on to our first question. Imagine you have a list of numbers. Your task is to find the pair within this list that offers the smallest sum parsable. In other words, pinpoint the pair with the lowest sum among all parsable combinations. Let's eagerly plunge into the thrilling conventional solution. This Python code finds the pair of numbers in list X with the smallest sum. It initializes the first pair as the assumed minimum sum. Then, it iterates through each pair of numbers, calculates their sum, and updates the minimum sum and corresponding pair if a smaller sum is found. Finally, it prints the pair with the minimum sum. This algorithm ensures every parsable pair is checked, guaranteeing the smallest sum is found. Now, let's examine the solution condensed into a single line. In this Python code, we find and print the two smallest elements from the list X. We achieve this by sorting the list first and then selecting the first two elements using slicing. The result, stored in required underscore pair, gives you the pair of the smallest elements. Jumping on to the next question, given a list of fruits, you are tasked with converting each fruit's name to uppercase using Python. The initial list of fruits is provided. Your goal is to create a new list, upper_case_ loop, that contains the uppercase versions of each fruit. Here is one of the solution. It starts with defining a list named fruits containing three string elements, apple, banana, cherry. The code then initializes an empty list called upper_case_ loop. Using a for loop, it iterates through each element in the fruits list, converts each string to uppercase using the upper method, and appends the result to the upper_case_ loop list. Finally, it prints the modified list. Now, let's examine the solution condensed into a single line. This Python code uses the map function along with a lambda function to transform each element in the list, fruits, to uppercase. It applies the upper method to each element using the lambda function and converts the result into a list, which is assigned to the variable upper_case. Write a Python program to print a right-angled triangle pattern using asterisks. The program should take an integer input n representing the number of rows in the triangle. This Python code generates a triangular pattern of asterisks using nested loops. The outer loop, controlled by I, iterates from 0 to 4, determining the number of rows in the triangle. The inner loop, controlled by j, prints asterisks in each row, with the number of asterisks increasing by 1 in each iteration. The n parameter in the print function ensures that asterisks are printed on the same line. The last print statement moves to the next line after each row, creating a visually appealing triangular pattern. Here is the one-liner for the same problem. The variable n is set to 5, representing the number of rows in the pyramid. Using a list comprehension with a join method, it creates strings with increasing numbers of asterisks based on the row number, then prints each string on a new line. As a result, the output forms a visually appealing pyramid pattern with 5 rows. Let's jump on to the next question. Design a Python program to calculate the factorial of a given positive integer n. The factorial of a number is the product of all positive integers up to that number. In this Python code, the variable n is initialized to 5, and fact is set to 1. The for loop iterates from 1 to n plus 1, multiplying each value with fact. This effectively calculates the factorial of n. After the loop, the final factorial value is printed, which, in this case, is 120. This concise script efficiently computes the factorial of 5 in just a few lines. Now, alternate approach. Here math module is imported, and a variable n is set to 5. The math, factorial, function is then applied to n, calculating the factorial of 5. The result is then printed. Now, let's move on to the next question. Create a Python script to generate a list of even numbers from 0 to 10, inclusive. The script should iterate through each number in the range, check if it is even, and if so, add it to the list named even numbers. Finally, print the list of even numbers. Now, let's initialize an empty list called even numbers, then loop through numbers from 0 to 10 using the range function. Inside the loop, we use the modulo operator to check if a number is even, and if so, we append it to the even numbers list. Let's check on how this can be solved in one line. This code creates a list of even numbers from 0 to 10 using a list comprehension. It filters numbers using the condition x%2 == 0. The result is assigned to the variable even numbers, and when printed, it displays the list of even numbers. Moving on to the next problem. Write a Python program to merge the contents of two dictionaries. Here, we have two dictionaries, D1 and D2. Through a concise loop, we're merging the key value pairs from D1 into D2. The result is a combined dictionary, and when printed, it shows the updated D2 with the elements from D1 added. Now, let's look at a couple of approaches to solve this in one line. Method 1 uses update to modify the first dictionary in place. Method 2 creates a new dictionary by unpacking both dictionaries using double asterisk operator. Both methods yield the same result when printed. Moving on to the next problem. Determine prime numbers within a specified numerical range. Let's check out the normal solution. The function is_prime checks if a number is prime. It returns false for numbers less than 2. Else it iterates up to the square root of the given number, checking for divisibility. A list comprehension generates prime numbers between 2 and 20 using this function. Finally, the prime numbers are printed. Here is the output. Now, let's check one-line solution. Here, we use a lambda function and the filter function to find prime numbers within the range of 2 to 19. The lambda function checks if a number is not divisible by any number in the range from 2 to itself. The filter function then selects only those numbers that satisfy this condition. Finally, we convert the result into a list and print it. Next question is, write a Python program that takes a list of elements and forms tuple pairs with consecutive elements in the list. Jumping on to the solution. Here, we have a list of students and their corresponding grades. The code creates pairs by iterating through the lists using a for loop. It combines each student with their respective grade into a tuple and appends it to a new list called student_grade_pairs. Finally, it prints the resulting list. Now, the same problem can be solved in single line as well. Here, we're creating pairs of students and their corresponding grades using the zip function. The zip function combines two lists, students and grades, into a list of pairs called student_grade_pairs. Finally, we print out these pairs. This is a concise way to associate student names with their respective grades. Write a Python program to address the task of counting the occurrences of each element within a given list. Here is the solution. This Python code demonstrates a function to count the occurrences of elements in a list. It uses the counter from the collections module to efficiently tally the occurrences. The function iterates through the input list, and for each unique element, it records the count in a dictionary. The example usage with the list is provided, resulting in a dictionary that shows the count of each element. Now, let's look at the one-line approach. Here, we're using a dictionary comprehension to create a count dictionary. It tallies the occurrences of each unique item in my underscore list. The set operator over list ensures we only iterate over unique items. Finally, we print the count dictionary. Now, the next question is to reverse the order of words in a given sentence using Python. Let's look at the longer solution first. Alright, the function reverse_words takes a sentence, splits it into words, reverses the order of the words, and then joins them back into a reversed sentence. The input sentence is processed using this function, and the reversed result is printed. Here is the one-line approach. We have a variable rev_op that reverses the words in an input sentence. The split function breaks the sentence into a list of words, and ::1 reverses their order. The join function then combines them back into a sentence with reversed words. Finally, we print the reversed output. Let's check out the last question of this video. Merge two lists into a single sorted list. Here is the first solution. Let's define a function merge_and_sort that takes two lists as input. It merges them into one list and then sorts that merged list in ascending order. It does this by initializing an empty list called sorted_list, then looping through the merged list. In each iteration, it finds the minimum value in the merged list using the min function, appends that value to the sorted_list, and removes it from the merged list. Finally, it returns the sorted_list. In the example provided, two lists, list 1 and list 2, are defined, and the merge_and_sort function is called with these lists as arguments. The sorted result is then printed. Now here is the one-line approach. The sorted function takes concatenation of both the lists as inputs, arranges the final merged in ascending order. Finally, we print the sorted result. In just a few lines, this code efficiently merges and sorts lists. Now let's have a look at reviews from our coding community to understand the sentiments regarding usage of one-line approach to solve the Python problems. Solving Python problems in one line offers concise and elegant solutions, enhancing code readability and promoting a mastery of a language. However, it may sacrifice clarity for brevity, making complex problems harder to understand. Additionally, one-liners could be less efficient for larger projects, impacting maintainability. Striking a balance between succinctness and clarity is crucial when adopting this approach. Thank you for watching. If this video added value to your Python journey, please like, share, and subscribe. Your support fuels our commitment to delivering valuable content. Happy coding!